Question, how many of you have compiled at least once MySQL from sources? Perfect. How many of you works kind of in DBA, SRE operations? How many of you are like developers, like using MySQL? And how many of you have you ever like worked as a embedded or firmware engineer or something like that? Awesome. Okay. Well, you have covered 90% of the talk already, so you have like 25 minutes. Now, okay. Well, I'm Martin Alderete. I work at Booking.com. I work as a principal SRE. And today I'm going to try to talk about MySQL Audit plugins. It's something that I wish I had known before, because there's no documentation about how to write good plugins, like at scale in production. There are a few examples of how you can write something which is a plugin, but there's nothing around the environment when plugin runs, the concurrency, what happens when things go wrong. So yeah, this is kind of a talk about my learnings. I'm not going to go into the details about how to write C++ code, assembly, or optimize everything for the critical path. But for me, it's more about like create a mental model around how MySQL plugins work, how they interact with MySQL server, and how we can build better plugins. A little bit about Booking. We have more than 200 MySQL clusters. Yeah. We run a lot of automation to being able to handle this. We run in multiple platforms, MySQL multiple platforms like bare metal, EC2, and also in OpenStack. And we run group replication and traditional replication. So let's go into kind of the talk. Let's start with the anatomy of a plugin, right? Let's start with a plugin. What's a plugin? We have like at least two definitions. One is like from an administrator, a DBA, and SRE using MySQL. We can say that it's a shared object that we load into MySQL, execute install plugin, and something happens. And when we don't need it, uninstall plugin, gone. But then from a developer perspective, as system engineer perspective, it's a shared object, it's C++ code that we need to build, and it's going to be loaded dynamically into MySQL process. So it's not going to be a sidecar, it's not going to be a different process, it's going to be in the same memory space of MySQL. So you can imagine that that is not a really safe environment to be. You can think about this model. You have clients, you have a host with MySQL D running. Inside there are some events happening, and those events trigger something which was loaded inside MySQL. And we run it, we run inside MySQL, so there's fire there. We load it once, and then we execute our plugin multiple times. That's kind of the mental model. You can think about three main functionality of the plugin: init for initializing, the init to go away, and notify to react. For those who want to know a little bit about C++ or how it looks, basic plugins are defined this way. Here you have some macros to define metadata around the plugin, the name, the description, who is the author, the version, blah, blah, blah. But the important bit is like the plugin init, which is, I'm giving you a pointer to a function that you need to call when I'm installing a plugin, a pointer to a function when I'm unloading the plugin. And then here's a different struct, which defined there, which basically we're telling, hey, I'm this kind of plugin, because MySQL has different kind of plugins, like clone plugins, storage engine plugins, authentication plugins. We're going to focus on the audit plugins. And for these particular plugins, we can connect to different kind of event classes, which are in this array. In this example, I'm hooking to a particular query event, which is call my plugin when the parser already finished parsing a query, it's validated, it's a valid query, and we are going to start executing the query. And those are the kind of events we can subscribe. Yeah, for those interested in C++. But now, where this thingy runs in reality? And now we have the client connecting to MySQL, and probably you all know that for every connection, MySQL creates a process, right? A response to the client, we need to finish the execution of our plugin, right? And this is happening synchronously in the thread. So a lot of things can go wrong here. And this is what I call the whole path, right? We are not in a really safe environment. We are in the critical path of MySQL. So if that plugin takes seconds, even if our query takes milliseconds, we are going to wait milliseconds plus the seconds that our plugin is adding on top of that. So this creates this mental model that the whole path is a place where our function notify the core of our plugin is going to be executed for every single audit event we are subscribed to. But if the plugin is slow, the whole MySQL is slow. And even more, if the plugin crashes, MySQL crashes. And spoiler alert, I will try to crash MySQL live at the end. Let's see if that happens. But this put in our, I want you to transmit that this is the model, and if we are building plugins, we need to be super efficient in what we are coding there. And there are a lot of tricks when you're coding there, like even using inline assembly, knowing your architecture, compiler tricks, a lot of things. But yeah, not everything is wrong, right? In the whole path, there are a few patterns that I want to transmit you. The notify function of the core of our plugin should be or must be super lightweight and non-blocking. That's kind of the first thing you need to keep in mind. It should not block. And some patterns that I find interesting are defensive programming. For those who have coding embedded systems or something super critical or constrained, you know that defensive programming is everything. Like basically you're paranoid, checking everything. If something could go wrong, you need to check for that. And here's the same. If you try to reach a pointer and that pointer is null, boom, you'll crash the whole MySQL. Early returns. You don't need to process things that you can avoid, right? If you know that the event you're receiving is not something interesting for you, just return. Say, MySQL, I'm not interested anymore. Keep going. Stack allocations. Raise your hand who knows what a heap versus stack allocation is. Okay. So basically that means don't use malloc or similars in the plugin. Try to avoid it as much as possible because that takes a lot of CPU and also fragmentation of the memory and stuff. So use the stack of your function as much as possible. Then try to do async work. If you need to like send data or connect to different components, use fire, forget, async, or even create a thread. But try to do everything non-blocking. Minimize lock, please. If you introduce more threads or whatever, try to minimize lock. That's sometimes impossible, but try to do it. And of course, your plugin should be small. Try to offload as much work as possible. And this is super important because remember, each microsecond counts here. Something we haven't talked yet. The function, the core of our function, when you write it or you read it, it seems like a simple C++ function that receives a thread and an event, and you can do whatever you want there. But there's nothing, even in the documentation of MySQL, telling you, be aware that this piece of code is multi-thread. And you don't see that, right? The environment is multi-thread by design, but you as a developer of plugin don't know that. And even if you go to MySQL source code and you see the example plugins, they have race conditions. Why? Because nobody thought about it. Because when you run a plugin in your machine with one thread, nothing happens. You have one connection, you execute it, 3 queries, nothing happens. But in reality, we're in a super concurrent environment. And this is the model. We have a bunch of clients, a bunch of threads, but all those threads needs to execute code in our plugin. So we are in the supercritical path now. And this is where most of the plugin goes wrong. Most of the issues that I see in plugins happen because of concurrency or null pointer exceptions and crashing MySQL. But again, taking this into consideration, we can think about, okay, how can we do concurrency inside plugins without pain or with less pain, because concurrency and pain are kind of together always. Try to do read-onlys for global variables inside your plugins. If you have variables need to share state, try to share through reads only. Atomic operations as much as possible. I mean, modern CPUs has instruction to do increments or decrements in atomic way, so you can rely on those operations rather than create mutex or logs and try to have contention there. Again, avoid locking inside the whole path, because everything that is blocking there is adding latency to your final user. When you need to use some data structures, apart from the arrays or whatever, sometimes you need circular buffers or stuff like that, try to go for the lock-free implementation when possible. There are a few of those. And again, try to offload as much heavy work as possible. A common pattern at scale with Audit plugin is to have a plugin doing minimal work and fire UDP messages. And then you have a different process doing the heavy lifting with those messages. Unix socket also works, but the idea is like try to offload work. And UDP is good because you fire and forget, so that works. Now we are reaching an interesting topic for plugin. If you have questions, please raise your hand. MySQL plugins are hidden. They expose zero visibility to us, zero. The only thing you can know is log into MySQL, and MySQL through MySQL shell, whatever, and see if the plugin is loaded or not. That's it. What happened inside the plugin? It is running, how many events I'm processing, how many events I'm dropping, how many bytes the plugin is generating, how many bytes the plugin has sent through the network. We don't know. By default, we don't know. And this is quite interesting, right? Because, for example, Booking, we have more than 10K servers. We cannot log into those servers and see if our plugins are running or not. So we need observability. And again, once I was thinking about it, I said, okay, probably we can like reinvent Prometheus, right? Having like something like counters and gauge and histograms inside MySQL. I said, no, but we are moving away from our objective of having something which is tiny, right? So we cannot rely on that. We cannot rely on creating an HTTP server for the plugin. However, plugins can expose global variables. And that's super cheap for MySQL, because we don't really need to write into a table. We don't really need to get a lock to write. We don't really need to handle metadata. We can just expose integers or longs in C++ that MySQL takes care of exposing those through show globals. And this way we can expose counters in a super cheap way without any extra C++ code, more than just defining, okay, this is a counter and you need to expose it with this name. We don't really need to push datagrams or packets through the network. We don't need to reinvent the wheel. And based on this, I've been working, we have been working with this kind of architecture in mind. Have you ever used MySQL DExporter? Anybody? MySQL DExporter is an open source project under Prometheus, I think, yes. Written in Go, which basically have different collectors which connect to MySQL and execute queries and expose those through Prometheus. So we can add this component. By default, it executes show globals. So everything that we expose using this mechanism of global variables to the plug through the plugin will be exposed by MySQL the exporter for free. So then we can configure Prometheus to scrape that MySQL the exporter, and for example use Grafana to see our visualize our metrics. This way we get like for free observability using super cheap tools inside MySQL and super like off-the-shelf processes. I think MySQL the exporter runs everywhere. And now, let's cross our fingers, please. I really don't like to do live demos, but I say, okay, let's try.
The demo effect will be that MySQL wouldn't crash, which is
Yes, that's the objective of the demo, having a plugin showing you a little bit of the code, how it looks like, and exercise the plugin. And if everything goes well, MySQL is not going to crash, and we are going to see some metrics in Grafana. Okay. This is the setup that I'm using. Everything is running in Docker. I have a few containers. I have a MySQL the exporter talking to a MySQL. And I have a Prometheus container, a Grafana container, and that container called devm is basically a container that I built from an image that I create with MySQL source code, GCC, and everything to compile. Because, again, plugins need to be compiled inside the source tree of MySQL. MySQL has a dash plugins folder, so you need to put your plugin there. And when you run make, the CMake and make will generate the shared object of your plugin. That's for free. If you put a plugin in that folder and you have the CMake files, MySQL will detect that it's a plugin and it will compile, hopefully.
Is it inside MySQL or do you still need to use install plugin?
Sorry?
Is it, when you compile it like that, is it inside MySQL directly, or do you still have to use install plugin?
You need to use install plugin, or you can tell in the configuration low when you start, in the start.
Okay.
Like for example, replication plugin, most of the time is there, or clone.
Yeah.
So now let's go to my terminal. Is it too small? No.
yeah,
Okay.
maybe a bit bigger.
It's not working.
Yeah.
Yeah. So I have 5 containers, that is as I mentioned. So I have, see, I started them before the talk. And I have Grafana in those containers using MySQL the exporter, and this dashboard came for free in MySQL the exporter. You just throw it there and you have a lot of data. But then I built another dashboard that should have no data because we don't have a plugin or the plugin is not loaded. So now I have a make compile. Yeah, I compiled before, so basically everything was pre-compiled. I'm cheating a bit. But yeah, we have a plugin now. Let me show you that is true. We have a share option there. Now I'm going to go into I'm going to get a shell into a MySQL container. That's a MySQL container. I'm going to log in into that server. And I'm going to select everything from schema, plugin, where name equals MySQL days. Or no, plugin name.
The quotes are not okay.
Thank you. Okay. Oh, where is
Plugins.
plugins? Thank you, Simon. Yeah, nothing. We don't have that plugin load. Okay, let's try to load it. install plugin, the name of the plugin, MySQL days. Zone name is the share object name, MySQL days.zone. Boom, loaded. It didn't crash.
Yeah, don't know yet because you haven't done it.
Didn't crash.
Yeah.
It's my plugin. It's my name. It's my plugin. So now, let's see what this plugin exposes. There are a few. Oh, it's too. Can you see it here at the bottom? Those are a global status variable exposed by the plugin. And hopefully, if I execute a few times, you will see this moving. Yeah. 19, 29, 29. Those basically is counting the number of query it sees. And also it's counting in microseconds how many microseconds we are wasting inside the plugin in total. So since I loaded this plugin, we have spent 81 microseconds. And
Also,
then
the query is probably coming from MySQL exporter.
yeah, no, this data I queried MySQL.
Yeah, but the total queries is probably coming from MySQL exporter running in the background.
No, this is the plugin exposing to MySQL.
Yeah, but
Yeah,
why
but-
is it increasing? Something is querying.
Oh yeah, sorry, yeah, exactly. That's my point.
Yeah.
Those total queries and this work is
Yeah.
because MySQL D exporter every 3 or 5 seconds is pushed. Is query. Yeah, thank you. Then we have this MySQL days total special queries 0. This plugin is quite dumb, but it's going to every time we execute a query and in the table that the parser sees is the special query table, it will count 1. For now, we haven't done it, so I don't have even the database, so let me, oh, sorry, I didn't create the database. I create the table, at least I have the table. 0 still. Let's insert 1 record from this. 2 records, why not? Two queries, right? The plugin is working. And it's not crashing. Yeah, and it's live. So now let's go back to the dashboard that I told you that I built that was no data. Now there's data there. This data we're seeing in Grafana is coming through MySQL D exporter querying MySQL. So our plugin just exposed a few variables to MySQL, and almost for free we get it here. So we can see like the total queries, the number of queries, basically it's all monotonic, incremental, the total time in the plugin, and then using those two variables we can kind of do math and say, okay, what's the average time we spend in the plugin per query? So it's the one here. And we are spending an average of 4 microseconds per query. The plugin is quite fast, it's not doing a lot. But at least you have some observability. And then there at the corner is the rate of special queries in comparison with the total of queries. So yeah, that's kind of the demo flow. But now, let's try to do something else. Let's think about, okay, it's working. We're in production, we have a dashboard to monitor a fleet, and eventually we found that we have an incident or something happened and we need to kind of say, hey, unload the plugin. Do something. This plugin is killing us. It's not easy because when you do an install plugin, the plugin will keep in memory until all the threads disconnect. So you have two options. Or you go and kill all the connections, or you pray, I don't know. But again, there's something in the plugins. Plugins can use system variables. So basically, we can tell the plugin, hey, expose a system variable to kind of enable or disable your behavior at runtime. So the plugin is still loaded in memory, but doing nothing. And you define that with kind of this line of C++. You say, okay, these are the system variables that I have, enable or disable. And then in your notify function, you do something like, if I'm not enabled, just return. And that's a kill switch. And then you can go one step forward and say, okay, I can have a sidecar running, listening for, I don't know, a feature flag in my infrastructure, and when that flag is triggered, that'll go and execute, disable the plugin in all the fleet. So this kind of notify, to me, is like a boilerplate that you can use. I will upload this to GitHub. You can use to write your own plugins. It has like early returns. It has event filtering. It shows how you can hook into the Lexer and scan the table and search for tables. And if the table is one of the tables that you consider special, do something. And it uses atomic fetch add. This is a GCC trick, but you can use std atomics. It's the same. So basically, under the hood, no locking. Everything happens on CPU. And yeah, this is the secret sauce. And everything else is kind of the infrastructure to have like reliable plugins. Going back, we didn't crash it. However, I crashed it before. If you see there's a message, I'm about to crash. And then there's a crash, it's my plugin. This is a attack trace on MySQL. I opened this bug 2 years ago in MySQL. I submit the patch, it was verified, but was not applied. So you can go and do exactly the same. What happens if you go here? Plugin can use a function called log service, something like that, to generate log messages. But if you pass a null pointer as plugin, it crashes. So you can go there. And you receive these beautiful stack traces. This is not with symbols, so you don't see it, but otherwise you will see that there's my log services. So yeah, take away from the top. Audit plugins are in the core of the whole part of MySQL, so you need to, for critical code, you really need to be fast, non-blocking, super performant, and observable. Plugins are multi-thread by nature. It doesn't matter if you are not thinking, oh, I'm not spanning new thread. You are in a multi-thread environment, so you need to live with that. Observability must be designed into the plugin. There's no way to observe at scale if you don't do it, although plan it. And always safety beats perfection in these cases. I mean, we don't want to crash MySQL, because crashing MySQL is quite expensive. If you need to decide on processing everything or dropping data, prefer to drop data inside plugins. And yeah, a good audit plugin should be visible until you need it. I always say that you need it from day one, but different. And yeah, that's my presentation. Questions? Any questions? Okay.
Is there a similar approach to components?
Good question.
Seems like everything's supposed to not be plugins anymore, but in components instead.
In my experience, based on the components that I review and the source code of MySQL, in the long run, probably components will take over. But at the moment, they are not, and not even, I mean, by design, they are not designed to replace them. For example, when you build a component, the contract is not explicit that you are receiving a thread. You don't receive the thread. You receive an event, and you can get the thread through some inner functions. So that contract is not really a contract. However, in audit plugins, the signature of the function is, I'm going to execute you with this thread. And then inside that, you can navigate everything from that thread. So for me, that's a design decision. Probably components are more for how you design MySQL to be more pluggable in terms terms of components, but no plugins inside the whole pack. These audit plugins, if you want to know more, you can go to these links, basically SQL plugins C++ and SQL Audit C++. You will see that that's basically also the parser itself. So you are and those events are triggered with the current.